Hello everyone, my name is Tingjun Chen. I'm here today to present our challenge paper on Cosmos, a city-scale programmable testbed for experimentation with advanced wireless. Cosmos is joined between Rutgers, Columbia, NYU, along with several partners including New York City, IBM, Silicon Harlem, the City College of New York, and the University of Arizona. The Cosmos project is supported by the National Science Foundation Platforms for Advanced Wireless Research Program. Our objective is to design, prototype, and evaluate technologies for the wireless edge to enable novel modes of interactions between city residents and the urban environment. We develop and deploy Cosmos, an open access, remotely accessible, advanced wireless testbed that supports real-world investigation of urban environments with ultra-high bandwidth, low latency, coupled with edge computing. Using this infrastructure, researchers can study the convergence and challenges of high-speed wireless access, edge cloud and networking, as well as optical xHaul for low latency applications. Some of you might be familiar with the Orbit testbed in WinLab at Rutgers. The objective of Cosmos is to develop the beyond 5G version of Orbit, take it outside, and to deploy it at city scale with cutting-edge hardware and software components. Here we show the detailed Envisioned deployment map of Cosmos in West Harlem, an area about 1 square mile, which you can also see from my virtual background. In the center figure, different colors represent buildings and assets owned by different entities, including Columbia, City College, and New York City. The Federal Communication Commission has designated that the testbed area as one of the nation's first 2 innovation zones, therefore making wireless experiments in this area much easier and more accessible. The colored lines here represent the dark fiber-based optical network as part of the testbed infrastructure, which provide high-speed connections between different Cosmos nodes and sites. The pilot phase completed in May 2019 focused on the Columbia campus deployment. We're currently in the phase 1 deployment, which focuses on the City College campus and the Amsterdam Avenue corridor. During the pilot phase, we deployed 2 large nodes, 3 medium nodes, and several small nodes, as well as the core optical switching complex that is connected to the Manhattan dark fiber. We also deployed 2 sandboxes at Rutgers at Columbia for experiments in controlled environments. To allow researchers to experiment with the testbed's full potentials, we designed and built Cosmos as a multi-layered computing architecture with programmability from the radio hardware layer up to the edge central cloud. Key technologies of Cosmos include software-defined radios, programmable mmWave radios, an optical xHaul network, software-defined networking and cloud, and a sophisticated control and management framework. Different paths here represent possible data routes supported by Cosmos, where data processing can happen at different distances away from where the data was generated. The software-defined radios in Cosmos offer full flexibility of spectrum use in sub-6 GHz. A subset of the nodes were also equipped with 28 or 60 GHz mmWave capabilities. Using our design, radio signal processing can be separated between the radio nodes and the edge cloud. The second key technology is a family of mmWave radios, and a main component is the IBM 28 GHz 64-element phased array antenna modules. The testbed also includes Sievert's IMA radios, Facebook Telegraph radios, as well as the interdigital EdgeLink and 5G new radio platforms. The next key technology of Cosmos is its optical transport network. On this slide, we show the core optical switching architecture of the testbed, which incorporates space switching and wavelength switching technologies using optical space switches and the Lumentum white box ROADM units. Cosmos also features a powerful core and edge cloud, whose logical topology overlaid on the optical network is shown on the slides. The edge cloud computing side contains CPUs, GPUs, and FPGAs to provide flexible and powerful processing capabilities. To help drive and validate the testbed design and architecture, we developed several Cosmos pilot experiments across the wireless, optical, and edge cloud domains. Example experiments include open access full duplex wireless using customized experimental hardware, converged optical wireless networking using Manhattan dark fiber, and the Cosmos smart intersections. We also developed the Cosmos Education Toolkit and worked with teachers on creating over 100 K-12 educational labs, which are used in high schools and different activities. We'd like to acknowledge National Science Foundation and the Platforms for Advanced Wireless Research Program. We also want to thank many people for their numerous important contributions to the testbed. With that, I'd like to conclude the presentation. Thank you all for listening, and please contact us if you have any questions.